You are given 24 inches of wire and are asked to form a rectangle whose area is as large as possible. What dimensions should the rectangle have? Alright, so if they tell us we have this piece of wire, it's 24 inches long, what are they telling us about the rectangle? The perimeter, right? So let's write example 1. We have our perimeter of our rectangle is 24 inches. And let's draw our rectangle. Generally, a rectangle has a width and it has a length. And so how do we find the perimeter of a rectangle? What do we do? Okay, so it has 2 widths plus 2 lengths, right? So we have a width here, a length there, and a length there. So we add those 4 sides together. 2w plus 2l equals the perimeter. But they told us the perimeter is 24, so we can substitute 24 into there. 24 equals 2w plus 2l. Alright. Now, they also told us we want to maximize the area. So we want to find the area of this rectangle and we want to maximize it, because there's lots of different rectangles we can make, right? We can make a long skinny rectangle, we can make a square, we can make just, you know, a rectangle like this. There's so many different rectangles and they can all add up to 24 different ways that we could bend the wire. So we want to find what's going to give us our maximum area here. Okay, so let's make an equation for area of our rectangle. I'm going to put area over here. How do you find the area of a rectangle? Length times width, right? Base times height. In this case, length times width will give us the area of the rectangle. Okay, so we have too many variables going on here, so let's solve for L and substitute in for L there. So let's solve this equation for L and substitute it into here so that we get rid of the L. Okay, so one thing I'm going to do, since these both have a 2 in them, I'm going to take a 2 out and put w plus L. 2 times w plus L equals 24. Oops, equals 24. And then just divide by 2 to get rid of that 2. Divide by 2. 24 divided by 2 gives me 12 equals w plus L. And then subtract w from both sides, that, and you get 12 minus w equals L. So now that we solved for L, I'm going to plug this 12 minus w in to my L right here. So my equation is the area equals 12 minus w times w. And so basically we have a function here. And, you know, our function is in terms of w, but usually we have a y and we have an x. So let's go ahead and multiply this out, distribute it to simplify it, and we get area equals 12w minus w squared. Like I said, this is just a function. Normally we have a function like f of x is equal to, you know, this is just 12x minus x squared. So we want to maximize this area and find what value of w do we put in here to get our maximum area. Okay, to do that we can use limits, and we can actually we can graph this and put this in our graphing calculator. So if I were to put this in my graphing calculator, what kind of graph would I get for 12x minus x squared? You get a parabola, right? It's an x squared, and there's a negative in front of the x squared, so what kind of parabola would you get? It's going down, right? It's somewhere on the xy axis going down. So to find what it looks like, let's put it in our graphing calculator. So get your graphing calculators. Since we're doing polar coordinates, let's get out of polar coordinates. Okay, so let's go to mode, press the mode button, and if you're still in polar coordinates, which you probably are, polar is over there, so change it back to function mode. Let's get it out of radians because we're going back to just regular numbers, so degrees. Okay, so change out of radians, go to degrees, go to function, get out of polar, and then we have to change our zoom factor, so our format. So press second zoom to change, because a lot of you are still in polar mode, so we need to get over to rectangular mode. And you pressed a second zoom there. Okay. Once we do that, then we can go back and put in our equation here Our equation is 12x squared minus x. I'm sorry, just 12x minus x squared. Got those backwards. So 12x, delete that squared. 12x minus x squared. Okay, that was our equation. When I try to graph this, let's see if I get my, okay, I don't get a parabola, and a lot of people have said, oh, they got a line. Okay, I kind of got a line. Well, this is the left-hand side of the parabola. The parabola actually goes over here. So I need to move my window to the right. So I don't need negatives, so I'm going to make my x go to the positives, and I'm going to make my y values go higher so I can see the... So you have to go to your window. You always have to fix your window when you're doing these problems. And my window is really small right now. So I'm going to change it to 0 for my x's, and I can change it to 10 for my maximum x. My y values, my minimum 0, and let's say, I think for this one we have to go really high up. I'm going to go to 50 because we tried 10, we tried 20, the last class period was too low. So I'm going to go all the way up to 50. Okay, and then press graph. Alright, got a pretty good graph. All I really care about is the maximum. You know, I could make my window, my x, go a little further. Why don't I do that? Why don't I go to 20 instead of 10? And then change, so it'll change my window a little better. So now I can see like the whole left and right side of the parabola. Of course, it goes on forever. So I want to find where the maximum is. So I'm going to press trace. Okay, so trace is this button right here, and then it'll pop up somewhere. I want to move it to the left and watch my values of y. Look what they're going to, because this is what we're interested in. This is going to be our area, and we want to see what the area is going to go up to, and we want to find what x value is going to give me my area, because that x value is the width of the rectangle. Right? So it's getting higher, 26, 20, 20, 28, 29, 30, 32, 33, 35. What is it going to go to? Close to, what do you think the top was supposed to be? 36, right? So x equals 6, 36. If we're not sure, let's type in a 6. So I'm going to press 6, and it's going to say x equals 6, and then I press enter, and it'll tell me what coordinate goes with 6. So at 6, the y is 36. So that's going to be our maximum. Okay, that's going to be the maximum area of 36 square units for a 6-inch width rectangle. Okay, so the way that we write that, we just found a limit. We found the limit, LIM, as x approaches 6, because that's where, you know, the highest point was, of our function 12w, or I should put x. I'll put 12x minus x squared, because this is an x. Our limit is 36, and that's your first example of finding a limit. So this point up here was 636. Okay, when we got to 6, the graph approached 6 from the left and from the right. So that's a real life example of how you could use this limits. Okay. Oh, definition of a limit. So next I want you to copy down this definition of a limit right here. Okay. This is the definition. You won't really understand it, but that's okay. Just copy it down. You'll understand it soon. If f of x becomes arbitrarily close to a unique number L as x approaches c from either side, the limit of f of x as x approaches c is L. This is written as the limit as x approaches c of f of x equals L. Okay, so go ahead and copy that. I'll pause it for a second.